Hey guys, Mr. Milton here. Today we're going to look at solving compound inequalities. At the end of this video, you should be able to solve and graph and compound inequalities. So compound word, as we get into this, is two words put together. Doghouse, keyboard, basketball. Okay. A compound inequality then is two inequalities put together. There are two types of compound inequalities that we'll look at in this unit, and those are and inequalities and or inequalities. Okay, we'll look at the first today and the second one in the next lesson. So let's look at and inequalities starting here. So find all numbers that are greater than 2 and less than 9. So here, notice that there are two inequalities here. Inequality 1 here says all numbers that are greater than 2. So if I was like numbers greater than 2. Inequality number 2 said numbers less than 9. Less than 9. So as we write this, another way of writing this would be, okay, I want all my numbers that are less than 9 and greater than 2. Okay, notice that this is eating the end. The alligator's eating the end, so it's greater than 2. Okay, a solution to this is a number that makes both inequalities true. Since there are an infinite number of solutions, we again need to graph to show all of our solutions. And yes, there is an infinite number. You might say like, oh, there's only 3 numbers, but remember that, or not 3, like 7. But remember that all the numbers in here, like 2.01, 2.001. Okay, so I'm gonna open circle for my boundaries, and then greater than 2 goes this way, and less than 9 goes this way, and they meet. So here's my inequality, my graph for x is greater than 2 and less than 9, or in this case. All right, next example says Monday's high temperature was 74 degrees and low temperature was 51 degrees. Show all temperatures from Monday. So here's my inequality. My high was 74, that's my upper limit, upper boundary. My low is 51, that's my lower boundary. And my temperature is somewhere in between here. Okay, so it was greater than 51 or equal to, because it actually hit 51. And then it was less than 74, equal to 74, because it was actually at 74 at some point. Okay, so as I graph this, 51, 74, these are closed circles because it actually got to that temperature. And then everything in between, there's my graph. Notice as we look at these two graphs really quick that, come on, buddy, that our inequality signs, when we put them in the compound inequality, always face the same way. And I mean that in the sense of like, hey, they always face left, but they always face the same direction. If one faces left, the other's going to face left. If one faces right, the other's going to face right. Okay, it's just something to keep in mind as we go on here. Okay, solving and inequalities. To solve and inequalities, we want to isolate the variable. Okay, the same as before. We want to isolate the variable. However, the variable is found in the middle of the two inequality symbols. These two inequality symbols create 3 sides to the inequality. Therefore, whatever you do to the middle of the inequality, you have to do the same thing to all 3 sides of the inequality. So basically, how I think of this is, you can really almost ignore the outsides at the beginning and just say, okay, what do I need to do to the middle to get x by itself, or to get the variable by itself? Then once you make that decision, just do it to every side. So again, we have 3 sides. Their inequality sign splits our inequality. So in order to get x by itself, I'm going to add 5. I make that decision, and then I make sure I do it to all 3 sides of this inequality. So negative 4 plus 5, 1. Sign stays the same, x, sign stays the same, 8. So now I've solved it as x is greater than 1 and less than or equal to 8. And so now as I graph this, 1, 8, I have an open circle at 1 and a closed circle at 8. And I squiggle, 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 squiggle. And there's my graph. All right, let's look at some more problems here. Okay, so let's practice with some more. Up here we have negative 12 is less than or equal to 3x, which is less than or equal to negative 3. Getting x by itself, I'm going to divide both every side by 3. And so I get negative 4 is less than or equal to x, which is less than or equal to negative 1. Okay, as I graph this, negative 4, negative 1, 0 will be somewhere over here. Okay, closed circle, in between. You'll notice with these and inequalities, it has to be in between the two numbers. Okay, make sure you set your number line up correctly, but if it's going to be and, it has to be greater than and less than something else in the middle. Okay. Number 2. Again, we're focused on how can I get x by itself. My first step is going to be to multiply by 4 to get rid of that fraction. So on this left side, I have negative 52, less than or equal to 3x minus 1, less than 20. Then I'll add 1 to every side. So I have negative 51 is less than or equal to 3x, is less than 21. And then divide by 3. So that's 7x 117, negative 17. Okay, negative 17, 7, close circle, open circle, everything in between, shade it. All right, number 3. In the middle, you could say to distribute, but here's what I'm going to do. Distributing is just multiplying. I really want to I'm going to want to get rid of this 2. So instead of distributing, I'm just going to divide everything by 2. That'll save me a step. Almost feels like it saves me 2 steps, but only 1. So in the middle now I have x plus 5, and now I have is greater than negative 4 and less than or equal to 5. This is subtract 5 from every side. And so I have negative 9 is less than x, which is less than or equal to 0. Open circle at negative 9, close circle at 0, everything in between, shade it. All right, last one in this section. I need to subtract 4 from every side first. So that leaves me with 10 is less than 2/3 x, which is less than 18. And then get rid of 2/3, I'm going to multiply by 3/2. Okay, on each of these. So here, we're left with x in the middle. On the left side, that's 30 divided by 2, which is 15. On the right side, that's 54 divided by 2, which is 27. And so x is greater than 15 and less than 27. Both of these should be open circles. Open circles, shade in between. Okay. Last one, let's make sure we pay attention to it, I guess is what it says. So if you have difficulty and you're like, wow, that's a lot that I have to keep up with, it's okay for you to split these up and basically say, okay, I'm going to deal with this one, and then I'm going to deal with this one, and then I'm going to put them together. So if that's the strategy that you need to take, go ahead and do that. But I'm going to just handle this the same. No, I'm not. I'll do it separately. So here I have negative 7, 3 minus 2x. I'm going to do this side. 3 minus 2x is less than or equal to 11. Okay, so I want to subtract 3 from both sides as I'm solving for x. I get -10 is less than -2x. And then in order to get x by itself, I had to divide by a negative number. Don't forget that when we divide by negative, we have to flip the sign. Okay, so this becomes +5. And now instead of this opening up towards the x, it's going to open up towards our number, x. We have x is less than 5. Okay, on the right side, I'm going to do this same kind of thing. I'm going to subtract 3 from both sides. Get -2x is less than or equal to 8. Divide by -2. And so we get x is greater than or equal to -4. Again, we had to flip the sign because we divided by a negative number. Okay, so as I graph this, I want to make sure, put this together, x is in the middle. It is greater than 4, greater than or equal to 4, and less than 5. Two numbers, 5, 4, greater than or equal to 4, that means a closed circle. Less than 5, that means open circle. Everything in between here. Okay, so that's end inequalities. Again, compound inequalities with and there, solving for everything in the middle, basically. Yep. So yep.